In this video, we're going to talk about mapping a figure onto itself, specifically with reflections. Rotations might come up a little bit, but for more on rotational symmetry and mapping a figure onto itself with rotations, please see the rotations weekly recap video. For the first one, it says a rhombus is graphed on the set of axes below. Which transformation would carry the rhombus onto itself? Please pause the video, take a look at the answer choices, and think about what you think it would be. Please do this for each of the questions, and then you can unpause when you have an answer to check. 3 of the answer choices are about reflections, and 1 is about rotations. In order for a reflection to map a figure onto itself, the line that you're reflecting over needs to be a line of symmetry. That means a line that divides the figure into 2 equal parts, 2 mirror images on either side of the line. In order for a rotation to map a figure onto itself, we need to be rotating around the center of the figure. So let's check out the answer choices one by one. Number 1, a 180-degree rotation counterclockwise, and the direction doesn't matter if we're rotating 180 degrees anyway, about the origin. So already I see that this would not work because our center of rotation is not the center of the figure. The origin is not the center of the figure. So that is gone. Number 2, reflection over the line y equals 1/2 x plus 1. When they give us the equation of a line, remember from Algebra 1 that we start graphing with the y-intercept, which here is plus 1. That means the line is going to intersect the y-axis at positive 1, which is right over here. The slope tells us how to move to get more points. Remember, slope is rise over run. So the 1 tells us that we're going to move up 1. And the 2 tells us that we're going to move right 2, rise over run, up and down, over left and right. So I'm going to start at the y-intercept, and I'm going to go up 1 over 2, up 1 over 2. And then to get points in the other direction, I can do the reverse. Down 1, left 2, down 1, left 2. And let's check it out. Now, we might think, okay, this is a line of symmetry. But it doesn't go from a corner to a corner to cut the shape equally in half. So even though it might look like it's mirror images on both sides, it doesn't go from a corner to a corner. And when I show you the other 2 choices, it'll be clear what I'm talking about. So the line y equals 0 is the line where all of the y coordinates are 0. So that is actually the x-axis, because if I take any point on the x-axis like this point, that is the point 0, 0, y coordinate of 0. If I take this point, 2, 0, y coordinate of 0. If I take this point, negative 2, 0, y coordinate of 0. In fact, any point I take along the x-axis will have a y coordinate of 0. So the x-axis is the line y equals 0. And clearly, this is not a line of symmetry. It doesn't even come close to making mirror images on either side of the line. So we can rule out this answer choice. So that leaves me with the last answer choice, the line x equals 0. The line x equals 0 is the y-axis, because if I take any point along the y-axis like this point, that is 0, 1, or this point, 0, 3. Or this point, 0, negative 3. All of the x coordinates are 0, no matter which point I take. So the y-axis is the line x equals 0, and that is a real line of symmetry. It goes from a corner to a corner inside the shape, dividing it into mirror images, clear mirror images on both sides. So hopefully comparing answer choice 4 to answer choice 2, we see why answer choice 4 is the correct line that when reflected over would carry the rhombus onto itself. Second question. The figure below shows a rhombus with non-congruent diagonals. Which transformation would not carry this rhombus onto itself. A reflection over the shorter diagonal, a reflection over the longer diagonal, a clockwise rotation of 90 degrees about the intersection of the diagonals, a counterclockwise rotation of 180 degrees around the intersection of the diagonals. So the intersection of the diagonals is directly in the middle of the shape, so the rotations could be good. Because if you rotate around the center of the shape, there's a good chance it might end up mapping it onto itself. Let's check out the reflections first. I don't know which one's the longer and which one's the shorter diagonal, but it doesn't really matter because we're checking out both of them. And as you can see here, it goes from corner to corner and it makes mirror images on both sides. Both of the triangles that it's split into are exactly the same. So this is not the choice we're looking for because it would carry the figure onto itself. Same thing for the other diagonal, corner to corner, mirror images, the exact same triangle on either side. So even though we said for the rotations that they're both rotating around the point that they need to rotate around to map it onto itself, the difference between the two is the angle, 90 degrees or 180. So 90 degrees, it's going to turn one time. So it kind of looks like it's standing up right now. It's going to look like it's on its side if we do 90 degrees. 180, we'll do it twice. So it'll bring it back to the way it's looking now. So answer choice 3 is the answer that we're looking for. 180 degrees will bring it back to itself, but 90 degrees will not. Which transformation does not carry the rhombus onto itself? This one's very similar to the other ones that we did. So let's try out the answer choices. A rotation of 180 degrees about the origin. The origin is not the center of the shape. That rotation cannot even attempt to work. A rotation of 180 degrees about the point 1, 0. That might work. Looks like it's the center of the shape here. We'll put that one on hold. Oh, the question is which one does not carry it onto itself? That's the first one. And just so we could see why the other ones work, so we just saw that answer choice 2 would work, even though I misread the question. For 3, that's the y-intercept of -1/2. It's kind of in between points. And then we go up 1 over 2 to get new points. And I'm going to go down 1, left 2 to get even more points. Down 1, left 2. And that is a line of symmetry. So answer choice 3 is a line of symmetry. And for answer choice number 4, the y-intercept is 2. This one's going to be easier to graph. The slope is -2 over 1, which means that we're going to go down 2 and right 1. Should be a decreasing line. And then I'm going to do the opposite to get more points on the other side. Up 2, left 1. And it is a line of symmetry. So the other answer choices work. The only one that doesn't is answer choice 1. We're rotating around a point that's not in the center of the shape. A square is graphed in the coordinate plane. A reflection over which line does not carry the square onto itself. So 3 of these are going to work and 1 is not. 1 is x equals 5. 1, 2, 3, 4, 5. That's the line x equals 5. It's going to flip over the line. It's not going to be exactly in the same spot. So that's the answer choice we're looking for, but let's check out the rest of them to see why the other answer choices do carry the square onto itself. Y equals 2. Line of symmetry right down the center. y equals x, line of symmetry through the diagonal. X plus y equals 4. Let's solve for y by subtracting x from both sides. So y equals negative x plus 4. So that has a y-intercept of 4 and a slope of negative 1. So y-intercept of 4, 1, 2, 3, 4. Slope of negative 1, down 1, right 1. Down 1, right 1. And that also is a line of symmetry. In parallelogram ABCD below, diagonals AC and BD intersect at point E. Which transformation would map triangle ABC? Let me outline that triangle, triangle ABC. So we need to map this triangle onto triangle CDA, onto this triangle. So we have a reflection over AC, that sounds reasonable. A reflection over DB, that's not going to work. It's going to make it go this way. A clockwise rotation of 90 degrees around point E. That's not really going to work either. A clockwise rotation of 180 degrees around point E. That seems reasonable. So I'm between A and answer choice number 1 and answer choice number 4. So let's try to narrow down which one it could be. So a reflection over AC. B will go to D. A and C are going to stay in the same spots. A is supposed to map onto C, so that's not going to happen. A is going to map onto A if we do a reflection, but A is supposed to match onto C, so that's not going to work. Whereas if we rotate the red triangle, then B will go to where D is, A will go to where C is, and C will go to where A is. So based on the lettering, answer choice 4 is the one that's going to work. That was a difficult one. Which transformation would not carry the square onto itself? A reflection over the y-axis. Well, there's our answer. It's not a line of symmetry. But let's go through the other ones to see why they would map the square onto itself. The x-axis is a line of symmetry. Look at that. Rotation of 180 degrees around the point 1, 0. The point 1, 0 is in the center of the square, so it would work. And a reflection over the line y equals x minus 1. So the y-intercept is negative 1. The slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1. That is a line of symmetry. A reflection over which line would carry the rectangle onto itself? Y equals 2. 1, 2. That looks like it could be a line of symmetry, but remember earlier in the video, we talked about how it doesn't go corner to corner. So I'm going to put this one on hold, but I'm thinking there's probably going to be a better choice. Y equals 10. Yeah, that definitely is not a line of symmetry. Y equals 1/2 x minus 3. So that has a y-intercept of 1, 2, negative 3. And up 1 over 2 is because that's the slope. And this looks like a better choice for a line of reflection. I think it's going to be this one. Let's graph the other one just to be sure. The other one has a y-intercept of 7. 1, 2, 3, 4, 5, 6, 7. The other one that we're trying is in red. And then down 1, right 2. That looks like it would work too. Yeah, both of these are lines of symmetry. So there's two answers that would work here. These would both work. Okay. Which transformation would not map the rectangle onto itself? A reflection over the x-axis? That would, because the x-axis is a line of symmetry. A reflection over the line x equals 4. 1, 2, 3, 4. Doesn't go through the corners. Maybe it's going to be that one. A rotation of 180 degrees around the origin. Oh, no, it's going to be this one. That is not the center. 1, 2, 3, 4, 4, 0 is the center of the shape. So it's going to be this one over here. Okay. Which transformation will not carry the rectangle onto itself? And we're going to pick the best answer. A reflection over the line y equals x. Okay, so we see what that looks like. A reflection over the line y equals negative x plus 10. This is 10, so that's the y-intercept. And then a slope of negative 1. And a rotation around the 0.66. And that's not in the center at all. The other 0.55, which was this one, is directly in the center. So that would be answer choice 3. Which transformation carries the parallelogram below onto itself? And keep in mind, parallelogram doesn't have 4 equal sides. The opposite sides are equal, so that might impact our answer a little bit. A reflection over the line y equals x. I mean, that looks like it would do it to me. Looks like a line of symmetry. Y equals negative x. Looks like a line of symmetry as well. A rotation of 90 degrees counterclockwise about the origin. I mean, that's in the center of the shape, but it's 90 degrees. And 180 degrees about the origin. 90 degrees. 180 degrees will make it look like itself. 90 won't. It's like standing up. That'll put it on its side. 180 will put it back the way it is now.